Hello friends, once again welcome back to my channel. In this video, we will see armature reaction and its effects in alternator or synchronous generator or simply in synchronous machines. Okay, we know that already we discussed about armature reaction in DC machine in detail in the previous videos. Okay. So here we will see armature reaction in alternator. From this name, easily we can understand that it is the reaction of armature. So armature reaction is nothing but the effect of armature flux on the main flux. That is, simply we can say armature reaction. We know that in alternators or synchronous generators, they are the main source for alternating current. So the alternator can generate alternating current and we will collect the alternating current from the alternator in generating stations. In alternator, the rotor is energized from a DC supply. Only excitation is needed for the field magnets. Here the rotating system is the rotor. So we will give excitation to the field. So we can say this type of machines or alternators are simply excited machines. When the rotor rotates, the rotor will rotate with the help of a prime mover. Okay. Whenever it starts rotates, then a rotating magnetic field will create in the rotor. We know that in generating stations, we are using a prime mover to rotate the rotor of the alternator and we will excite the field of the rotor with the help of an external DC source. When we excite the field with the help of this DC source and if we try to rotate the rotor with the help of prime mover, then a rotating magnetic field will set up around the rotor. And this rotating magnetic field will cut the armature conductor. So that EMF will induce in the armature conductor because it is closed one. So current will induce in the armature conductor and we will collect the current from the armature. That is the main working principle of this alternator. But the point is that if there is no load is connected across the alternator, then the entire induced voltage will be appear across the terminal side. So the entire induced voltage we can collect from the terminal side. That means from the armature. The condition is at no load condition. Okay. So when the armature is loaded, then what will happen? Armature current will start flows through the armature winding. So it will produces its own magnetic field. So when the magnetic field or magnetic flux induced in the armature, according to Lenz's law, this induced armature flux will try to opposes the cause of producing it. So here the cause of production of armature flux in machine is nothing but main flux. So due to the main flux, armature fluxes will generate only when the machine loaded. So the armature flux will try to oppose the cause of producing it, that is the main field. So the armature flux will opposes the main field fluxes. That is exactly armature reaction. And after the result of this armature reaction, what will happen? The net flux inside the machine will decreases, or the resultant flux will decreases due to this opposing action of armature flux. So the terminal voltage across the alternator will reduce. That means we will not get the exact voltage which is induced in the armature. So some reduction in voltage will be there due to this armature reaction. That means the reaction of armature flux to the main field flux. Here you can see a schematic arrangements for main flux, armature flux and the resultant flux. Here you can see this portion will indicate the main flux. Okay, these two lines will represent the main flux. When the machine loaded, then what will happen? Armature current will start flowing through this machine and armature flux will start flowing through this, and this will be just, you can see if you notice this arrow mark, this red line or the red portion indicates the armature flux. The direction of the armature flux is sometimes just opposite to that of the main flux. Here you can see the direction of main flux. So that means when the machine started, due to the presence of armature current, armature flux will generate and that will opposes the main flux. As a result of that, the net voltage appearing across the armature will be reduced. In the result of that, the resultant flux will be less when compared with the generating voltage. So the resultant voltage and resultant flux will be less. The violet colored portion indicates the resultant flux. Okay. Based on these concepts, we should remember that this armature reaction is not always same. But the armature reaction or the armature flux is mainly depends on the load, means the load power factor. So based on that, the effect of armature reaction with the different loads, we can discuss about that points. Okay, first we will see the armature reaction in alternator at unity power factor loads. We know that unity power factor loads means it will be a resistive load. In resistive loads, current and voltage, both of them are in phase. And as a result of that, due to armature reaction, due to the presence of resistive load, what will happen? This upward arrow indicates phi A. Phi A is nothing but flux due to armature. So phi A is armature flux. And this line to the left region indicates phi M. Phi M is nothing but main field flux. So here you can see the direction of armature flux will be in quadrature with the main flux. That means the angle between the armature flux and the main flux can be 90 degree. So we can say the flux at the air gap will be distorted one. So this armature reaction at unity power factor load will be purely cross magnetization. So the armature reaction at unity power factor will be purely cross magnetization. So that armature flux and the main field fluxes which are in quadrature with each other. Okay. The second point is what will be the armature reaction at zero power factor lag. Means zero power factor lag means it will be purely inductive loads. So zero power factor lag means purely inductive, then zero power factor lead means purely conductive. Okay, we will discuss about purely conductive loads in the next slide. Okay, so here in purely inductive loads, power factor will be 0 power factor lag, and here phi A and phi M, both of them are opposing each other. That means the direction of, if the direction of the main field is moving from right to left, then the direction of armature flux will be from left to right. Both of them are opposing each other. As a result of that, the net flux will be, or the resultant flux will be the difference of these two flux. That means resultant flux is phi r is equal to phi m minus phi a. So net flux will be reduces. As a result of that, reduced voltage will appear across the terminal side. So the terminal voltage will be reduces due to this effect, and this effect is known as purely demagnetization effect of armature. So this type of armature reaction will be purely demagnetization when, if the load is purely inductive at 0 power factor lag time. Okay, so you can remember these points, very important for technical exams. So at 0 power factor lagging, since the resultant flux is very less and the terminal voltage is very less, so we need to improve the terminal voltage. So we over excite the field. So at demagnetization effect of armature reaction, an alternator will be overexcited, or overexcitation is needed for alternator when purely inductive loads are connected to it. So these terms are very important. And the third condition, at 0 power factor leading, that means purely capacitive loads. At purely capacitive loads, what will be the effect of armature flux on the main flux? In this figure you can see, if the main flux is moving from your right to left, then armature flux will also move from right to left. That means both of them are aiding each other, or both of them are in phase with each other. As a result of that, what will happen to the resultant flux? It will be very high, because the resultant flux phi r will be equal to phi m plus phi a. Their sum will be the resultant flux. As a result of that, we will get an increased terminal voltage at the terminal side. That means the terminal voltage will increases when the load is purely capacitive or at 0 power factor leading time. Okay. So we need to reduce the terminal voltage. So to reduce the terminal voltage, we can say that under excitation is needed. That means the excitation to the field will reduces. So we can say under excitation is needed at this time when the alternator is connected with purely capacitive loads. Okay, these red colored portions are very important. Okay, so at purely capacitive loads, armature reaction will be purely magnetizing. Magnetizing means both the fluxes are aiding each other. So they are magnetizing. So due to this magnetization, terminal voltage will reduces. So to reduce, terminal voltage will be very high. So to reduce the terminal voltage, we under excite, or the excitation to the field windings will reduces. So the name under excite the field of the rotor. The fourth important condition is that at lagging power factor loads. Lagging power factor loads means there will be the effect of two loads. One load is resistive load and the other load, that is inductive load. So the resultant of this resistance and inductive loads, it will give you lagging power factor. Okay, here you can see this is the direction of the main magnetic field and this is the armature flux. Why? Because this armature flux will be moves from here to this region due to the influence of phi AC and phi AD. So what is phi AC and phi AD? Phi AC is nothing but the flux due to resistive load. So flux due to resistive load will give you purely cross magnetizing effect. Okay, so that cross magnetizing effect is indicated by the letter C. So phi AC is the flux due to pure resistive load here. And phi AD is nothing but the flux due to inductive loads. We know that a pure inductive load will give you demagnetization effects of armature. So the combination of this cross magnetizing and demagnetizing effects will be there in lagging power factor loads, means RL loads. So the result as a result of that, armature flux will be like here. So it will move in this direction when compared with the direction of main magnetic field. Okay. So at this condition we can say, that means during lagging power factor loads, the armature reaction is partially cross magnetizing and partially demagnetizing. So partially cross magnetizing is due to the presence of resistive load and partially demagnetizing due to the presence of inductive loads. And finally, we are going to see at leading power factor loads. Leading power factor load means there will be two loads. First load is due to resistive load and second one is due to capacitive loads, that is leading power factor loads. Here you can see in this diagram, this direction will indicate the flux due to main magnetic field and here it will be the direction of armature magnetic flux. Why? Because of the presence of phi AC and phi AM. Phi AC is nothing but the flux due to the presence of resistive load. That means armature reaction will be cross magnetizing due to the presence of resistive load. And in the case of pure capacitive load, what will be the direction of the flux produced by the capacitive load? That will be phi AM, and phi AM is nothing but the flux due to magnetization. Magnetization means both fluxes are additive. So phi AM, or the flux due to capacitive load, will be in the same direction as that of the main magnetic field. So as a result of that, the net armature flux will be like here. So we can say for leading power factor loads, that means RC loads, the resultant flux will be partially cross magnetizing and partially magnetizing. So this is the major points about the armature reaction and its effects. Okay, thank you.